the Mram, right? With the Mram, what we have to do is we have to calculate the midpoints of each of them. So this is, this is a quarter. Okay, and then the midpoint here is 3/4, 5/4, 7/4, 9/4, and 11/4. Okay? So with the midpoint, you cap it off. So you go up at the midpoint and you cap it off that way. All right? So Mram, we're going to be efficient this time because the half, right? That half is the length of each, is the base of each of the rectangles, and it keeps repeating. I can just do it one time and then take each of the values here and put it in the function. So 1/4 squared, 3/4 squared, 5/4 squared, 7/4 squared, 9/4 squared, and 11/4 squared. So that's count, always count to make sure you have 6 of them, right? And together this becomes 8.9375. Okay? All right. Huh? Yeah, I rounded to 3. I got a little excited there, so I guess 938. Okay. All right. So now, you're not going to be given the same information every single time. Sometimes all you have is a data set, like this one. This is a table that shows the velocity of a model train engine moving along a track for 10 seconds. So somebody just recorded, right, the velocity every second for 10 seconds. Again, we want to estimate the distance traveled by the engine. Well, we can do that because each time, what did we need? We need time and velocity. And if you have time and velocity, then you can calculate the distance, right? Now, we're going to do 10 subintervals of length 1 with Lram and Rram. So take a look here. Let's translate this to what we know. What we've seen, or what we're used to, is this: V and T, right? So look at what you have here. You have time at 1 second intervals. So 0, 1, 2, 3, 4, 5, and so on. At t equals 0, it's 4. At t equals 0, it's 4. At t equals 1, it's 12. At t equals 2, it's 22, and so on and so forth, right? Now, if I wanted to do Lram, I have to create rectangles here and cap them off at the left endpoint, right? So for the first one, do you see how that's what the rectangle will look like? And then here, that's what the rectangle will look like, and so on and so forth. So let's do a Lram. Okay. The intervals along the time axis is the length of each of the bases. So you see here from one to the other, it's an interval of 1 second. So your base is equal to 1. These are the respective heights here. Okay? So now, for Lram, okay, so each of the rectangles is going to have a base of 1 times, now we're going to do each of the heights. For the first rectangle, what's the first height we're going to use? 4. All right, so basically what you do is, okay, so for this one interval, it's 4. For the other one, it's 12, then 22, and so on. And you add up all of them, except for the last one. Plus 2 plus 6. You omit the 0.
Why is it all times 1 again?
Because that's how much the base is. So for each rectangle, it's 1 times 4, 1 times 12, 1 times 22. It's the height, it's the width. Okay?
If it was Rram, you wouldn't include the first one.
Exactly. And for Rram, it's again 1 times, this time, for the first rectangle, it's 12. So you start 1 in, and you go all the way through. Okay? So 12 plus 22 plus 10, 10, no, 110. Oh, I have 2 10s before. Okay. All right, so 4 we don't have to do. So 12, 22, 10, 5, 13, 11, 6, 2, 6 plus 0. And that's 87 inches. Okay? So you see how for the Lram, you start with the leftmost point, the first one, and you have to go until the second to the last. And then with Rram, you start with the second and you go all the way over. Yeah, okay? All right. So let's do example 3. A particle starts at x equals 0 and moves along the x-axis with velocity equals 6 for t is greater than or equal to 0. Where is the particle at t equals 6? Okay, so v of t is equal to 6. So the way this looks is this. So v of t is equal to 6. And at t equals 6, this is what we're looking at. So that's distance is 6 times 6, 36. No units here either, right? That's it. Okay. Oh, I like this next one. A particle starts at x equals 0 and moves along the x-axis with velocity negative 2t plus 6. Ooh, plot twist. Let's just graph that one, right? Let's see what the velocity looks like now. Negative 2t plus 6. This is the y-intercept. So you go down to over 1, and then when y is 0, t is 3, right? So that's how it looks. Right? You want the particle, you want the position of the particle. Where is the particle at t equals 3? So basically, how much has it traveled, right? If it starts at x equals 0, how much has it traveled this whole time? Well, again, it's the area underneath, but this time it's not a rectangle, it's a triangle, right? So the distance is half times 3 times 6, 9. All right. So next one. A car comes to a stop 10 seconds after the driver applies the brakes. Oh. Look at this here. A little controversy between brakes. See that? They're spelled differently.
Oh. Yeah. That's what caused. That's what you said.
Didn't you write this?
I did. I'm just noticing I have a typo.
First one's wrong. Yeah, the first one's wrong.
Huh? I know.
No, I think the first one's wrong.
No, the first one's break. It's like a break.
Like he
Yeah,
applied the
the
brakes.
brakes.
Okay, anyways. While the real brakes are on, the velocities of the car are listed below. And we want to use the midpoint approximation with 5 subintervals of equal length to estimate the distance the car has traveled. So 5 subintervals of equal length, meaning, take a look here. Lots of things happening here. We've got 10 seconds here, but we want to split it into 5. What do you call it? Subintervals, right? Exactly. So the subintervals, you take the entire distance, entire interval, which is 10, divided by 5. Each base has a length of 2. Okay. But I want to take the midpoints. I want to do an MRAM. So that's the first interval from 0 to 2, right? Then from 2 to 4. Then from 4 to 6, 6 to 8, 8 to 10. Yes, we've visualized it now. Okay, each of these rectangles has a base of 2 times. Now, I need to take the midpoints, right? I need to take the y value of the midpoints. That means it's this one, this one, this one, and these two, okay? Because from the interval 0 to 2, the midpoint is 1. So which value do I put here? What do I put here, 1 or 76? 76, because it's got to be the y value, the height. Okay, good. So 76 plus 57, 42, 29, and 3. I need to take all of them this time. And again, stop and count. I need 5 rectangles. 1, 2, 3, 4, 5. That's how you can tell if you took the right amount, too much, too little, and so on. Okay. Right? So this is 414. What's the unit? Feet. Distance. Good. Okay. Last but not least, the table below records the velocity of a car in miles per hour at different intervals over 25 seconds. Use Lram to approximate the total distance traveled. Okay, you've got a little hint there, which you will not have any other time. And the hint says, note the difference in units. Okay, because look. Hours and seconds. It's time and velocity. Time is in seconds, and this is miles per hour. And remember, to find distance, you have to multiply time by velocity, right? But it'll be miles per hour times seconds, so they're not going to cancel out. You have to do a little, you have to change the seconds. Okay, so here's what we're going to do. We want to use Lram. So first, you have to go through and look at the intervals. So each interval here, 4, 2, oh my gosh, they're different. They're not the same. Do you see that? The rectangles are not of the same size. So they're not of the same width. So I can't just put one number outside. I have to do each rectangle separately. So here, t equals 4, and then 2, and so on. Okay, and then how many? 3, 1, 4. Somebody was like really. Yep. Okay, so let's go. All right, so here's what we're going to do. The first rectangle is, and we're doing Lram, so 4 times 0 plus 2 times 20. Okay, so first I start with this one, and then 2 times 20. Then 3 times 31. 1 times 47, 4 times 50, 3 times 52, another 3 times 54, 1 times 60. How much is this? 4 times 56. All right? Yeah. You still have to do the, yep. Okay, so if I multiply all this out, okay, if I multiply all this out, check out what I have. I have 982. The value is 982. Let's talk about units for a minute. This was in seconds, and these were miles per hour. So what I have now is seconds times miles per hour. But I have to convert. I have to convert this seconds to hours in order for me to be able to cancel.
360. Yeah.
Right, so 1 hour is 3,600 seconds. So this is 982 over 3,600 miles. That is 0.2727 miles.
0.273.
Yes. Okay, now sometimes they will ask you to put it in feet. Okay, so if asked to convert to feet, then it's 0.2727 miles times how many feet to a mile? Almost. See?
I thought it was like 50 to 80.
That's what it is.
We're supposed to know that.
440.27
We also
feet.
with this.